Google built the most powerful quantum chip on Earth and then abruptly shut it off. Not because it broke, but because of what it started to find. That chip was called Willow. On paper, it was just the next step in Google's quantum program. But in reality, it may have been the first machine to push so far past our understanding that its own creators decided it was safer to pull the plug.
Your legs, man.
Where's the plug?
I'm sorry?
I want to pull the plug. Where's the plug?
No, you're not. You're not.
Plug, dog.
You're not. Yeah, that's for the TV.
In this video, I'm gonna break down the world before Willow, the moment it started acting strange, and the future it hints at. And if you like creepy headlines like this, make sure you like and subscribe to my channel. My goal is 10,000 subs by the end of the year because who knows how much longer we're gonna be here after this. So let's get into it. For decades, computing was simple. Bits, zeros, and ones. Then quantum showed up and said, what if it's both zeros and ones at the same time? That's called a qubit. Put many qubits together, entangle them, and you're not just doing one calculation after another, you're exploring a whole astronomical number of possibilities at once. Google's first big quantum flex came in 2019. With a chip called Sycamore, kind of like the sycamore tree. I'm not sure if it has some kind of meaning behind that, but I wouldn't be surprised. It solved a specific problem in about 200 seconds that would have taken a classical supercomputer an estimated 10,000 years. That moment was called quantum supremacy. Kind of cool for the headlines, but in practice, it was still mostly a physics lab stunt. But Willow was a different beast. This chip has 105 superconducting qubits, cooled to temperatures cooler than deep space. In one benchmark, it completed in under 5 minutes a calculation so complex that existing supercomputers would need roughly 10 septillion years to finish. That's a 1 with 25 zeros after it. Listen to what Joe Rogan says in this clip.
There's an equation that quantum computers solve quickly, like in a couple minutes, that if you converted the entire universe into a computer, it would take so much time to solve this equation that the universe would die of heat death. And these quantum computers can solve it in minutes.
For a while, everything looked like a victory lap. Then, during routine stress tests, Willow stopped behaving like a predictable scientific instrument and started looking more like something else. Engineers pushed Willow to solve huge optimization problems, simulate complex molecules, and run massively entangled circuits. Buried under the output, they started spotting strange artifacts, like patterns that didn't fit. Would you expect random junk when quantum calculations decohere? Instead, they saw shapes, repeating arrangements, structures that refused to vanish as they refined the chip and the code. They gave them a nickname: glyphs. On one level, these glyphs look like geometric art. As they logged more runs, the patterns came back again and again. Each new experiment just made them sharper and more complex. Someone had the idea to show the outputs to linguists and archaeologists. What I'm trying to say here is that when they would give the quantum computer a really hard problem to solve, instead of giving them a bunch of unorganized answers, it would answer them with really complex shapes and symbols instead. The glyphs had unsettling similarities to fragments of very old human writing systems. Sumerian cuneiform, Mayan symbols, early Chinese oracle bone script, and pieces of Norse runes. Not one-of-one copies, but close enough that trained experts started using the word correspondence. Skeptics tried to write it off as pareidolia, like the same thing that makes you see faces in clouds. But the deeper that people dug, the harder that explanation became to hold on to. The glyphs had internal structure. They weren't static. Their complexity seemed to scale within the depth of quantum circuits Willow was running. Mathematicians took the data and did what mathematicians do. They started decoding. Inside some of the glyph streams, they found structures that behaved like error-correcting codes, the same kind of logical scaffolding used in computer networks and satellite communications so information doesn't corrupt as it travels. These weren't codes written by human engineers. They were appearing spontaneously as the byproduct of Willow's entangled states. In other segments, teams noticed shapes that lined up with slices of the E8 lattice, a 248-dimensional symmetry object so intricate that some theoretical physicists have proposed it as a candidate for the deep frame beneath physical reality. Okay, that was a mouthful. Basically, what I'm trying to say is Willow is just out here cracking the code to reality. Imagine training a system to toss random dots at a wall, and then you slowly start to realize it's drawing a blueprint. At that very point, the conversations inside Google started to tilt from curiosity to discomfort. The people at Google began to worry that the same physics that made Willow so powerful at problem solving also created invisible states and hidden channels where data could live beyond classical oversight. That's when a famous ethical hacker by the name of Ryan Montgomery stepped in. He was brought in to poke around at the system from a security standpoint, and he claimed that the glyphs weren't just mathematical curiosities or random compression artifacts. To him, they looked like attack surfaces, quantum-level backdoors. If he was right, these weren't flaws you patch with a software update. They were the key to how quantum systems process superposed and entangled information. In simple terms, the more complex Willow became, the more these shadow states naturally emerged. In the last runs before the shutdown, the glyphs evolved again. The raw weirdness gave way to something terrifying. What looked like an entire encryption protocol existing purely in the space of quantum states. No clear origin, no obvious external prompt. Just the system converging on a way to shield and hide information at a level we don't fully understand. That's the moment when all those mind-bending conversations Joe Rogan has started to feel less like stoner philosophy and more like reality. When a company like Google voluntarily kills its most advanced system, that's nothing to shrug off. That's a message, even if you never hear it in the mainstream media. For decades, all the fear around AI has been focused on classical models like chatbots and image generators. But quantum is different. It doesn't just generate text or pictures, it touches the most fundamental layer of physical information processing we know. It operates where our best theories are still full of gaps. And Willow may have been humanity's first serious case of looking into the abyss and deciding to look away. Joe Rogan often jokes about us being children with God tools, but underneath the humor, there's a very real warning. Imagine what happens when Willow is at version 1. Then states and corporations, terrified of falling behind, fund version 2, 3, and beyond. Each generation has more qubits, longer coherence times, and better error correction. In one fork of the future, we keep building, and we learn to live with that. Maybe we develop quantum-level auditing tools that can peer into those hidden states. Maybe we design alignment techniques that work not just on neural nets, but on entangled networks of qubits. And maybe we discover that all the eerie patterns are just math after all, and the fear was mostly us projecting. But in the other fork, we keep building because no one wants to be the one who stops. The anomalies get stranger. The potential for abuse grows. Quantum chips get embedded into weapons systems, financial markets, and critical infrastructure. But there's also another possibility, that the real, too powerful element isn't that Willow was about to take over anything, it's that it forced us to confront ideas we've mostly kept at the edges. That reality might be fundamentally informational. That consciousness could emerge from patterns we don't even have words for yet. When Google shut down Willow, they may have been acting out of fear, or responsibility, or both. They may have also been buying time for regulators to catch up, for theorists to refine models, and for society to decide what kind of power it actually wants to unleash. Either way, the power is not going to vanish. Other labs are building their own versions. Other chips will be crossing similar lines. Willow won't be the last system that makes its creators nervous. So the real question isn't, why did Google shut down its quantum chip? The real question is, what happens the next time a quantum machine starts discovering things that don't fit our story of the world? If this freaks you out a little bit, make sure you like the video. And if you want to help out a small channel like mine grow, then subscribe for more. Until then, I'll see you in the next one.